As we finish up rationalizing the denominator, this is the last part of our simplifying radical expressions. We're going to be fully simplified, have no radical left in the denominator. And that's called rationalizing the denominator. So to rationalize the denominator, we have to multiply both the numerator and the denominator by the radical in the denominator, and then we get to simplify. Let's try some examples. So we're going to find each, write your answer in simplest radical form. So I have this, 7 does not break down, but I'm going to multiply by radical 7 on top and on bottom. That'll give me a radical 49 on the base, which is the square root of 49 is just 7. So now I have 4 radical 7, and I'm done. Number 14, I got a radical 5 and a radical 2. They don't simplify. So I'm going to multiply by radical 2 on top and on bottom. That gives me radical 2 times a radical 2, which happens to be radical 4, which the square root of 4 is 2. So now I've got inside times inside. So 5 times 2 is 10. So radical 10 over 2. Now the 10 is on the inside, and the 2 is on the outside, so they do not reduce. This next one, as I have the square root of 81 over the square root of 2, I break them down. And hopefully you realize that 81 is a square root, or a perfect square, so that becomes 9 over radical 2. Now 2 does not break down, so I'm going to say times the radical 2, that's radical 2, which is radical 4, which then now is just 2. So now I have a 9 radical 2 over 2. And my outside numbers, the 9 and the 2, do not reduce, so therefore I am done. Number 6 would be the radical 6. Oops, actually, you know what we can do? 6 over 18 reduces. So 6 goes into 6 once, 6 goes into 18 3 times. So now I have the square root of 1 over the square root of 3. What is the square root of 1? 1. So now I have 1 over the radical 3. From there, I'm going to go ahead and rationalize the denominator. So multiply by radical 3. So it gives me square root of 9, which is then just 3. So now I have 1 radical 3 over 3, or just radical 3 over 3. Number 17. This one I've got a 3 and a 2 on the inside. They don't reduce, but I can rationalize the denominator by multiplying by radical 2, top and bottom, which is square root of 4, which we know is 2. And over here, I've got the 4 on the outside, but 3 times 2 is 6 on the inside. And now, what can these outside numbers, do they reduce? And actually reduce. 2 isn't it once, 2 isn't it 4 twice. So it's 2 radical 6. And 18, 4 and 3 don't reduce. If I rationalize, I multiply radical 3. And I get 3 on the outside. So it gives me a 30 on the outside and a radical 12 upstairs. Now, we could have thought, oh, wait, 4 is a perfect square, and gotten that to be a 2. So then I had to do this. Instead of just 3's, this is going to be 2 radical 3. Now, 2 and 30, they reduce because 2 and 30 can reduce. They're both on the outside. So 2 goes into 2 once, 2 goes into 30, 15. I got radical 3 over 15. If I didn't see that and I stayed with the 12, it'll work out the same. I'm just going to show you real quick. So if I didn't see that piece and I went ahead and multiplied it out, got radical 12 over 30. Well, 12 breaks down to 4 times 3, and the square root of 4 is 2, so it would have been 2 radical 3 over 30. And then reduce it and get your radical 3 over 15. Next ones, we're almost done with these. I've got a 12 and a 10 both on the inside. They can reduce. So this divided by 2 is 6. This divided by 2 is 5. So I've got 5 radical 6 over radical 5. Rationalize the denominator by multiplying by radical 5 on top and on bottom. So now I have 5 radical 30 over 5. And the 5 will reduce, so I just get radical 30. And the last one, that's on the outside, and that's on the outside. 6 does not break down, but we're going to multiply by radical 6 to rationalize down to the 6. So 5 times 6 is 30. And on top I have 2 radical 6. And again, that reduces to 1 over 15. So radical 6 over 15. That's it.